and students were asked about what their favorite sport was at different ages. The relative frequency table shows the results. So relative frequency, you should automatically be thinking decimals or percents, and they're giving you a relative frequency table. And if you looked at it, they're all decimals, as expected. They do have, when it's a relative frequency table, it's always in related to the grand total. We don't know what the grand total is. Like, we don't know how many people were surveyed. So we just have to go based on the relative frequencies. But other than that, like when you answer these questions, you would do it the same as if these were like full numbers. Okay, so it says, which of the following statements are true based on this information? So first we have the probability that a student is 14 to 16 years old, given that the student likes basketball, is 0.08. So you have to read all of them closely. Let me scroll. But when it says things like given that, or among those, or out of, whatever follows that is going to be your denominator. So when it says given that the student likes basketball, well, how many students like basketball, or at least what number is for the total that like basketball? Good, 0.35. So again, I know it seems weird because it's like a decimal, but we just have to go based on what they give us. Here's the total that like basketball. So given that the student likes basketball, that means that's my denominator. My numerator is going to be out of the students that like basketball. Just looking at this column, how many of them are 14 to 16 years old? .08. So then I need to divide that, and 0.08 divided by 0.35 is 0.23. Okay, so the probability that a student's 14 to 16 years old, given that they like basketball, so that is not true. So we're not going to pick A because it's not true. And of course, it could be shuffled on yours. We're not picking this A. So then do what B says. The probability that a student is between 11 to 13 years of age, given that, so whatever follows given that is going to be your denominator, given that the student likes baseball. So how many total students like baseball? 0.25, so that needs to be my denominator. So then out of the students that like baseball, how many of them are 11 to 13 years of age? Okay, good. We're going to divide that out, see if it's 0.34. And I get 0.48. So we're not going to pick this B because it's telling me that it should be 0.34 and it's actually 0.48. Does that make sense? So all of these you just have to read really carefully. And now let's see the next one. So probability that a student likes football, given that the student is between 8 to 10 years of age. Okay, so what follows given that is your denominator. How many students are between 8 to 10 years of age? Okay, good. So that's going to be my denominator. My numerator is out of these students, the ones that like football is how many? So that'll be my numerator, divide that out. 0.12 divided by 0.35 is 0.34, not 0.12. So by process of elimination, it looks like I'd have to pick B that's on my options, but let's see what B is. So it says the probability that a student likes baseball, given that the student is between 11 to 13 years of age. So let me go back up to my table. How many total students are 11 to 13 years of age? So then that's my denominator. And we want to know out of those students, how many like baseball? 0.12. So then now we're dividing that. 0.12 divided by 0.35 is 0.34. So on my screen, it's D. It could be different on yours, but it's the one about a student liking baseball, given that they're between 11 to 13 years of age. You see how D is different from D? They're almost exactly the same wording, but it's like switched around. So anything that follows given that, among those, out of, that's your denominator. So question one. All right, questions on others? Mary was driving home from California. The following graph records her distance from home and the time spent driving. So just keep that in mind. Distance from home and time spent driving is what we're comparing. So it also doesn't have these labeled. You could label them if you want. What's independent should go on your X. What's dependent should go on your Y. So what depends on what in this situation? Does her distance from home depend on how long she's been driving? Or is how long she's been driving depending on her distance from home? So what should my Y-axis be labeled? Distance from home or time spent driving? Okay, good. And then that means my X is time spent driving. Reason why that helps is because when it's asking you to interpret slope and y-intercept, it helps. So this one says, which of the following statements are true regarding slope and y-intercept? So the slope of the line is -50. So you have to calculate the slope. In this one, you can actually see some of the points really clearly. So I would pick maybe like these and connect them, pretend that's connected to this one. What's my rise going from 200 to 100? Well, it is 5 spaces. We're going down 1, 2, 3, 4, 5. But if I started at 200 and I'm going down to 100, what's my rise going to be? And it's going to be negative because we're going down from left to right. But yes, -100 for the rise. For the run, do you see how these are counting? We're going from 2 to 4. So what's my run when I go from 2 to 4? 2. Is to go from 2 to 4. That's 2 spaces, right? So focus less on this, focus more on like the difference in the numbers. But yeah, so then when you do rise over run, it becomes -100 over 2. Does that equal -50? So then we should pick A, at least A on my screen. The slope is -50. But it's a select all that are true, so you gotta read all of them. But questions on how to find slope. Okay, so y-intercept is 6. You can see the y-axis where it touches. Does it touch the y-axis at 6? Touches at 300, so don't pick the one that says y-intercept is 6. Do pick the one that says the y-intercept is 300 because we just looked at it, which is 300. The slope represents how many miles she still has to travel. So remember slope, what's another word for slope? Another phrase for slope? Slope always tells you this about the equation or the situation. It's always what it is. I've talked about it so many times, I'm not gonna flat out tell you again. I guess you could say average what, though? Slope is always your tells you how much the situation is linked for each interval. If my slope is -50, like -50 what? Well, I'm not gonna flat out tell you, so we can just stare at each other until someone figures it out, but. Slope in any situation tells you how much the situation is blamed by. Decreasing or increasing by, what it's changing by. Slope is your rate of change, so remember that, put it on a flashcard, do something, but like, that's like very basic. Slope is rate of change. So in that case, it's changing by 50, and since it's negative, it's going down. But in this situation, 50 what? Is it 50 miles that she still has to travel? Does that make sense? It doesn't. It does not make sense. What it probably means is what it's decreasing by each hour by 50 miles. But what C says is how many miles she still has to travel. That's not what it is. She does not still have to travel 50 miles. It's what she traveled in like an hour. Make sense? So don't pick C. I'll be showing up on my screen. Now for E, the y-intercept is how far she is from home when she starts driving. So think about that. My y-axis starts at the 300. If you put it in coordinate form, it's 0, 300. Remember, x-axis was time. Y-axis is distance. So y-intercept is always when x is 0. So when it's 0 hours, she has 300 miles still to go from home, because that's what we said the y is. So does the E option make sense? The y-intercept is how far she is from home when she starts driving. Yes. When she starts driving, that starts the time, right? So 0 for the time. And that's how far she is from home is what the y-axis we said. So that so far makes sense. See the other options. We know the slope is not -65, so don't pick that one. Does the slope represent her average speed? So remember, slope was -50. Is this her speed, -50? I would say no. We'll see what the key says, but I would say no. You could say her average speed is 50 miles per hour, but the slope itself is negative. So I would not say that -50 is her speed. So I would not pick that one. If you rephrase it, sure, then you can. But last one, the y-intercept is how fast she needs to go in order to get home in 6 hours. Does that make sense? Does it say speed on the y-axis? No, it doesn't. It says distance. Y is your distance from home. So yeah, I would pick just those three. Let's see what the key says. Yeah, just those three. Slope is -50, y-intercept 300. Y-intercept is how far she is home when she starts driving. The slope is how many miles she's traveling, or like how many total miles it's decreasing by each hour. So it's negative. So questions on this? Okay, questions on others? I think you guys got that constructive response practice then. Have it out on like the corner of your desk. I'll check it like the last few minutes of class, because nobody in here got the 80% or higher on that when I checked it earlier. Okay, number 3 on the constructive response. So each day, Ty exercises by first doing sit-ups and then running. Make a scatter plot of the total time she exercises as a function of the distance she runs. And draw a trend line. So this kind of helps you out and tells you what should be your X and what should be your Y. So follow that. This is my X, this is my Y. That's how they label the axes. So all of these are coordinates. So 223 looks like they're counting by 5s. 223 would be like right here. 2.5, 28 would probably be here. 334 right here. 3.5, 34 right here. And 4 up 40 right there. So first you make your scatter plot, and then you draw your trend line, line of best fit, whatever you want to call it. What's the criteria for a good line of fit? It has to go above, middle, or under the data. Has to go through the middle of your data where the points seem to be clustered around it. So if it were me and I would use my line tool, but you guys would just have to try to make as straight of a line as possible where it looks like your points are clustered around it. So probably something like this. Kind of moved it a little bit. Let me try adjusting. Okay, I think that looks good. So going through the middle of your data where the points seem to be clustered around it. Then, so that's what the first step was, draw a trend line. You have to plot your dots and then draw it. And then it says a line to model the data is given by 6x plus 12. So they're not saying that's the line of best fit, they're just saying someone modeled it using that equation. The first question says, is the line given a reasonably good fit? So what do you guys think? Do you think that equation is a good estimate of this line? Okay, and why do you think so? Okay, so do you think it looks like it has a slope of 6? And a y-intercept of 12? Oh, no. Okay, so that's what this is asking, is compare it to this equation. Now, so you're saying no, and you need to explain why. So how would you explain why? Well, first of all, y-intercept is like 8, this, and okay, so let me see. You could say no because the y-intercept is closer to 8, you could say. And the slope is closer to, you said 10?
Yeah,
And did you do the math or did you,
I just looked at Rise of the Run, it looks like it goes like up 20 and over 2.
so then I would include those like calculations or whatever in my justification. So what I would do to figure out if that's a good line of fit or not is I would do like what we did earlier in number 1 and find 2 areas that it looks like it goes through really nicely. So again, I picked probably this one, 440. And let's see. It does look like it goes through this data point really nicely, and we know the coordinates of that one, so I'll do 334. That's 2.5 actually, sorry. Because that's this data point. So I'll use that because the other parts of my line don't look that easy to see. But again, they don't have to be data points. They can just be anywhere on the line you drew that it looks like it goes through really nicely. So then you could, in your justification, include like you solving for the slope. And here's that formula again. I'm not providing you that formula, just so you know, so have it memorized. It's like rise over run. And you could even do like the rise over run here, but I don't recommend that when it's not evenly spaced. But I would just make one of these x1, y1, the other one x2, y2, and then plug it into that formula. So I would do 40 minus 28 over x2 is 4 minus 2.5. So 40 minus 28 is 12 over 4 minus 2.5 is 1.5. So then you need to divide that out. 12 divided by 1.5. And you get 8. So yeah, the slope is closer to 8 as well. And I'm out of room a little bit, so I'll write it over here, my calculations. But I would say no, because the y-intercept is closer to 8. I would agree with you there. It looks like either an 8 or a 9. And the slope is closer to 8. And then you could include your calculations of that to help explain your reasoning. Make sense? All right. So yeah, that's just a bit farther off. I mean, it's not like completely far off, but there's a better line of fit for the model. So then the rest of it, explain the meaning of the slope. So we found the slope to be, and I do kind of want to see what the real y-intercept is, so let me find that too. I know it looks like it's at the 8 or the 9, but let me just solve that. So for that, you would pick one of your coordinates, so like 440 that was on the line. Make that x and y. We said the slope was 8, so when you plug it in like this, 40 for the y, 8 for the m, 4 for the x, you can solve for b. So what's 8 times 4? 32 plus b, get the b alone, opposite of adding 32, we need to subtract it. And we do get that b is 8, so that makes me feel a little bit better about saying the y-intercept is supposed to be 8. Questions on that process? Okay, but so if we're talking about the slope, my slope is 8. The meaning of it in this situation, you have to relate it to like the real world problem. So it was talking about him working out or she working out, and let me go back up to my graph. Remember, slope is rate of change. So if it's going up by 8, what is 8? With my rise. Representing. All right, my slope is 8, which if you make that a fraction, it's 8/1, so rise over run. Rise would be your y-axis. What does my y-axis say? Like on the label, what does it say? It says time in minutes. So that means 8 minutes per every one, what does my, says miles, per every 1 mile. So that means, it takes them 8 minutes to run 1 mile. Does that make sense? On average. You can say something to that effect. 8 minutes to run 1 mile. So we'll read what the axes say, know that slope is rise over run, rate of change, that's what it's changing that. For C, describe the correlation between the variables as either strong or weak and either positive or negative. So looking at the graph on your paper, I don't want to scroll up again. Would you say that it's strong or weak? And what makes it, how do you know it's strong? So then when you're explaining, you could say strong because all the points are close to the line of fit. Because that is what makes it strong. I'll do trend line, make it shorter. So strong because all the points are close to the trend line. And then is it positive or negative? Positive, and how do you know it's positive? Sorry, one more time. Because it's going up from left to right. You could say that. You could say because as X increases, the Y increases. Or something to that effect. You could say it's going up from left to right. Just try to use like complete sentences. But yeah, when we describe this correlation, it is a strong positive correlation. Okay, I'm gonna come around real quick before you leave, don't put it away, and update those points from earlier.